How's it going, Titans? This is Mr. Sturts with your last video of the year. We're going to kind of run through this final review packet, problems 38 through 70. Feel free to fast forward through any of them until you find the problem that you're stuck on. We're going to start with 38. This is x-intercepts. We need one that has an x-intercept of -5 and 3. So what we're going to do is we're going to use our x method. If we start with problem C here, or option C, we need two numbers that multiply to -15 and add up to 2. We know we can use 5 and 3. But we need a positive 2, so we have 5 minus 3. Now, if we take our two answers and set them equal to 0, we have x plus 5 equals 0, and we have x minus 3 equals 0. To find our x-intercepts, we need to solve for x. So we have x equals -5. If we add 3 over here, we get x equals positive 3. And there are our two intercepts, so our correct answer would be C there. 39, we need axis of symmetry. This is -b over 2a. Okay, and to do that, remember we have A, B, and C here. So -b, the opposite of B, if we look at A, B is 6, so the opposite of 6 is -6 over 2 times A. Well, there's a 1 before that x squared, so 2 times 1 is 2, equals -3. That's our axis of symmetry, so we see that A is the correct answer. For number 40, we need, again, to find our axis of symmetry, so we need -b over 2a. Well, they already found that for us. They found it to be 4. What we need to do is plug it in until we get an answer of -6. So we need to try each one of these until we get an answer of -6 when we plug in 4 for x. So if we plug in 4 for x on the first one, for a, we have 4 squared minus 8 times 4 plus 10. So we get 16 minus 32 plus 10. So we have a -16 here plus 10. And that gives us our -6. Okay, so we see that answer A would work there. Alright, now sketching the graph of each function. Remember, if there is a number between 0 and 1 before our x squared, we know that's going to make our graph a little wider. Okay, that graph's going to be a little wider if that number is between 0 and 1. Now it doesn't translate left to right, it doesn't move, so we know our vertex is still at our origin. This squared makes it U-shaped. So what we're going to do is our parent graph goes through -1, 1, and 1, 1. So we know it's going to be a little wider. So if we just had to make a sketch, okay, and on the final you're probably just going to have to match it to the best graph, the one that closest matches what they give us, that quadratic that they give us. This is what it's going to look like. Okay, now remember this negative actually flips it on 42, so it's going to open down. That big 2 is going to make it a little narrower. So it's going to open down and be narrower, so it looks something like this here. Alright, 43. Now, this is actually shifted. Okay, we don't have, from our parent function, we know it starts at 0, 0, but this -2 we think opposite when it's in the parentheses, so it moves it right 2. So we go right 2, and then this moves it down 1, so it goes down 1. It opens up because this number is positive. So if we were to sketch this, okay, it's going to go about right here. Okay, so go ahead and try that same thing for 44. 45, simplify. We need to do a factor tree. Okay, remember if there's nothing here, our index is 2, so we're circling pairs. If we do a factor tree for 32, we know 2 goes into that. 2 and 16. We can do 4 and 4, 2 and 2, and 2 and 2. So now we're going to write them all out under one long big square root here. We have 1, 2, 3, 4, 5 2's. And we're going to circle pairs and bring them out front. We bring one out front for every 2 we circle. So we're going to bring one of these out. We're going to bring another one out. So we have 2 times 2 out front and 1 left underneath. So our answer is 4 square root of 2. I do the same thing for 46. Now you have variables. That to the 4th power just means there are 4 x's and 4 y's. Alright, now remember down here, if there's a 3, we got to circle groups of 3. So this factor tree, same as 45, so we know there's going to be 5 2's underneath. 1, 2, 3, 4, and 5. Now we're circling groups of 3. And for every 3 we circle, we bring 1 out front. So we have 2, and underneath we have a 4 left, and don't forget your little cube there to make it a cube root of 4. Alright, 48, we can rewrite it as the square root of 4 over the square root of 81. Now we know what actually both of these square roots are. The square root of 4 is 2, the square root of 81 is 9. And we're finished there. On 49, we have a square root in the denominator. We got to get rid of that. So if we multiply by square root of 2 over square root of 2, and we multiply straight across, I'm going to move down here so we have more room. We have to rewrite it as 5 square root of 2. They're not like terms. We can't combine them. So those stay the same. And then remember our shortcut. Square root of 2 times square root of 2 is just 2. Alright, solve each by taking square roots. Okay, 50 and 51 are the same. I'm going to work through 50. You can do 51. Remember, we take the square root of a squared to basically undo it. That square root undoes that squared. So all we have left is x plus 4. Now, important part, plus or minus here. Don't forget that plus or minus. That means we have to split it. X plus 4 equals positive 6. X plus 4 equals negative 6. And then we solve. Okay, subtract 4. X equals 2, and x equals negative 10. Go ahead and try 51 on your own. Solve each by factoring. Okay, now before we can factor, we got to have it set equal to 0, so we need to move our 8 to the left side. So add 8 to both sides. So now we're left with x squared minus 6x plus 8 equals 0. X method now. We don't have to do the box because there's no number out front. If we do our x method, we have a positive 8 up top, and we need to add to get to a negative 6. So if we use 4 and 2, and we make them both negative, now we're going to set them equal to 0. So we have x minus 4 equals 0, and x minus 2 equals 0. So our two answers here are going to be x equals 4 and x equals 2. Okay, go ahead and try 53 on your own. Alright, now completing the square. Okay, we had a bunch of steps for these. Our first step was to move our 89 to the other side. Okay, we're going to do that first so we can complete the square. So we have x squared plus 12x. Remember to put your plus blank in there on each side to remind you that you need to complete the square on both sides. And how we complete it is we take half of this 12. Okay, that's an ugly looking 12. We take half of that number and square it. So half of 12 is 6. 6 squared is 36. We're going to add 36 to both sides. Now we can rewrite this left side. Okay, it's a binomial squared. So we can have x plus, and we said half of that middle number. Okay, half of that middle number is 6. Equals our right side. If we add those two numbers together, it looks like we get about 125. Now, we're back to the problem that we just worked. We got to square root both sides. Square root both sides. Those cancel each other out. X plus 6 equals, now we're going to get a decimal here, and that's okay. Plus or minus 11.18. Okay, about there. Now we split and solve. So x plus 6 equals positive 11.18, and x plus 6 equals negative 11.18. So we're going to get x equals about 5.18, and x equals negative 17.18. And then 55 is kind of the same way, follow those same steps. 56, find the height of the object after 4 seconds. All we need to do is we know that t stands for time, so let's plug that 4 in for t. So we have negative 16 times 4 squared plus 120 times 4 plus 50. And now we're just going to solve. Remember, order of operations, very important here. Do your exponents first. So 4 squared is 16, so we have negative 16 times 16, which gives us negative 256. Plus 120 times 4 is going to be 480, plus our 50 still. And if we add all those together, combine those, we get 274. So that is our height after 4 seconds. Alright, solve each by taking square roots. Okay, before we take square roots, we want to isolate the x squared. So let's move the 9 over. If we do that, we get x squared equals, what do we get there, about 43. Now we got a square root to undo the squared. We know those cancel, so we have x left. Equals plus or minus, very important here, two answers. 6.557. Okay, same thing on 58 there. Quadratic formula. Okay, hopefully maybe we remember that song. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we called what's under that radical, we called it the discriminant. Let's go ahead and find that first. Okay, Okay, if we label our A, B, and C here up top, remember A is 6, it's the number out front of x squared, B is 3, the number out front of x, and C is negative 84, don't lose that negative. If we find that discriminant first, B squared, so we have 3 squared minus 4 times A, which is 6, times C, which is negative 84. Okay, and we do that math, we combine them all, we're going to end up getting about the square root of, well, not the square root yet, we're going to end up getting 2016. Okay, and that's our discriminant. That's b squared minus 4ac. Now we can just plug it into our formula. Negative b is the opposite of b, so negative 3, plus or minus the square root of the discriminant we got, 2016, divided by 2 times a. Well, a is 6, so 2 times a is 12. So now if we solve that, the square root of 2016 is about 44.9. So we have negative 3 plus or minus, don't lose that plus or minus, about 44.9 all over 12. Okay, now we need to split it and solve it. We have negative 3 plus 44.9 over 12, and negative 3 minus 44.9 over 12. Okay, and if we do that math in the end, we get about 3.5, it looks like, and about negative 4 down here. Okay, 60, follow those same steps, use that quadratic formula. Alright, 61. Now we need to start checking for extraneous solutions. Remember, that means when you plug it back in, it doesn't work. Okay, so to undo this square root, we're just going to square both sides. Again, those cancel each other out. So we have k equals 25. And if we look, the square root of 25 is 5, so that does work. I do the same for 62 there. 63, we got to get the square root by itself first, so let's subtract 5 first. We have square root of n equals 4. If we square both sides, n equals 16. If we plug it back in, the square root of 16 is 4. 4 plus 5 is 9, so that one's okay. That works. Alright, solve each, check for extraneous solutions again. Now, to undo these square roots on both sides, we're just going to simply square both sides. When we do that, we are left with k minus 2 equals 18 minus k. All those squareds did was undid the square root. It didn't do anything underneath the square root. They just got rid of them. Now we want to get the k's to one side and our numbers to the other. So if we go ahead and add 2 here and also add a k to both sides, we're left with 2k over here equals 20. Divide by 2 on both sides, and k equals 10. Okay, do the same for 66 there. Now let's look at 67. A little tougher here. If we square one side, we have to square the other, and that squared undoes that square root, so we have 12 minus x equals x squared. Now we want to get everything to the x squared side, so we're going to add x. We're going to subtract 12. So we're left with x squared plus x minus 12 equals 0. Okay, now we need to do the x method to solve. So we have negative 12 up top, and we have 1 on the bottom. If we multiply to get to negative 12, add to get to 1, we know we can use 4 and negative 3. Okay, and to finish that out, we have x plus 4 equals 0, x minus 3 equals 0. And now solve. We have x equals negative 4, and x equals positive 3. Okay, if we go ahead and plug those back in to check them, if we have a negative 4, if we try to plug this in for x, a square root is never going to give us a negative answer. Okay, so we know that that one's extraneous, it doesn't work. But if we try the 3, 12 minus 3 is 9, the square root of 9 is 3, that one does work. Alright, again, all we need to do here is to undo a cube root, we're just going to cube both sides. Okay, so cube both sides, those will cancel. Kind of do our same steps. X minus 2 equals 3 cubed. Well, 3 cubed, 3 times 3 is 9. 9 times 3 is 27. If we add 2, x equals 29. Alright, and that is it for your review. Hopefully you've been able to work through this a little bit. Thank you for watching. Again, fast forward, rewind, go back, work through those problems that you're not quite sure of to prepare yourself for the final. Thank you for taking time to watch. Have a good rest of your night.